Hi, I'm Jacob Kaplan.
And I'm Kiran Patel, and this is our video on the geological history of California, all the way from 500 million years ago to the present day.
We learned a lot over the past few weeks and are excited to share some of the information with you.
Before we begin, we need to explain some basic geology concepts to help you understand the amazing and complex story of how California came to be.
All igneous rocks in the world can be divided into three categories. The first category is igneous rocks. Igneous rocks are formed by the cooling of magma from the mantle. The mantle is the section below the Earth's crust and is made up of the magma or molten rock. There are two types of igneous rock. The first is intrusive. Intrusive igneous rocks are formed when magma slowly cools in a chamber located inside the Earth's crust. Extrusive igneous rocks are formed when magma breaches the crust and rapidly cools. The process where magma leaves the crust are known as volcanoes. An example of an intrusive igneous rock is granite, which, due to the long cooling period, forms visible crystals. An example of an extrusive igneous rock is rhyolite, which chemically is almost identical to granite, but has much smaller crystals due to its more rapid cooling. We found escarpments made of granite in the Sierra Nevadas and found rhyolite to be most abundant near volcanoes.
The second category is sedimentary rocks, which are created when the wind and rain erode rocks to create sediments. These are then carried by streams into lakes and oceans. These sediments pile up into layers that are compressed to form sedimentary rocks. An example of a sedimentary rock is greywacke, which is often located on or near the coast of the ocean. We found greywacke at Point Bonita.
The third category of rocks is metamorphic rocks. Metamorphic rocks are formed underground and are composed of rocks that have been exposed to extreme heat and pressure. The heat and pressure cause physical and chemical changes, such as compressing the rock into an oval-like shape and forming bands/veins of color around the rock. The physical and chemical changes help us identify the direction of the pressure. In our research, we found that if heat and pressure are applied to the igneous rock basalt, it will turn into greenstone, which is a metamorphic rock. The same goes for shale, which is a sedimentary rock that will turn into slate, a metamorphic rock, if it undergoes extreme heat and pressure.
The Earth's crust is made up of plates, which are commonly known as the tectonic plates. The tectonic plates are what make up the crust of the Earth and are made of igneous rocks. It is believed that there are two general types of plates. The first is oceanic, which is denser than the other plates because it is made up of heavier minerals. Oceanic plates are mainly made of basalt. The second type is the continental plate. Continental plates are less dense than oceanic and mainly consist of granite. These plates are constantly moving due to magma currents below them and often interact with each other. Plates can converge, which means when they collide. Plates can also diverge, which is when they move apart. And finally, they can have a transform fault, which is when two plates slide past one another.
500 million years ago, the continents were divided into a completely different arrangement than they are today. The North American plate was much smaller. In fact, the only part of today's North American plate remaining intact is the North American Craton, and in the present day, that stretches from Wyoming to the East Coast. The original North American plate didn't include any of the western coast or even Florida. During the late Devonian period, around 350 million years ago, the North American plate collided with the Pacific Oceanic plate in what is known as the Antler Mountain Building Event, or the Antler Orogeny. Often, when plates converge, the denser of the two slips beneath the lighter plate in what is known as subduction. During subduction, part of the Earth's crust can be folded by compression to form a mountain range in what is known as an orogeny. The collision from the Antler Orogeny smashed oceanic sediments into the western edge of the North American plate. The crushing of these sediments resulted in an immense heat and pressure, which soon transformed the sediments into metamorphic rocks. These rocks make up what is known as the shoe fly complex, which now forms the eastern Sierra Nevada. Around 335 million years ago, the continents drifted towards each other and formed a supercontinent called Pangaea. Pangaea slowly formed and then began to break up again. About 200 million years ago, during the late Triassic time, a rift formed in the Atlantic Ocean, which caused the North American plate to move west and break away from Pangaea. The new North American continent then collided with the Farallon plate to the west. The second orogeny, the Nevadan orogeny, created what is known as the Calaveras complex, which is now a long central strip of the Sierra Nevada. Then, a similar process formed the Western Jurassic Belt, which makes up the western region of the Sierra Nevada. A multitude of orogenies created different subvertical terrains throughout California.
The friction of subduction melts crust into magma. The magma rises through the crust and creates volcanoes further inland from the subduction zone. The ash and pyroclastic flow formed by the magma leaves the crust and pile around the volcano, creating a mound of molten debris. The more the volcano erupts, the more the mound grows. Eventually, it can turn into a full-on mountain such as Mount Shasta or Mount Lassen. Mount Lassen, which is located in Northern California, is still active and is testimony that there is a subduction zone occurring in the northern section of the West Coast today.
Between all plates are faults. When plates move, stress builds up between them. If enough stress builds up, the plates will crack, creating a fault. Because the plate must exist in order to break, we know the fault will always be younger than the rocks they separate. The San Andreas Fault, one of the most well-known and studied faults, was created 30 million years ago when the Farallon plate subducted underneath the North American plate. At that time, the North American plate was moving west until it hit the forming ridge of the Farallon plate. The Farallon plate subducted under the North American plate until all that was left was the Pacific plate. When the North American plate hit the Pacific plate, they formed a new plate boundary, the San Andreas Fault Zone.
For reasons which are debated, the North American plate began to stretch. The stretch eventually caused normal faults, which allowed blocks of the North American crust to sink further towards the mantle. As the blocks sink, they moved off the surrounding crust. As the blocks slide down and off, the surrounding crust, now with less pressure above it, began to rise. The lowered blocks of the crust is referred to as the basin, and the risen part, the range. The cliff formed above the fault that separates the two is known as an escarpment. As the continental plates are mainly made up of granite, escarpments often display huge walls of granite, as is evident in Owens Valley. Basins and ranges are evident from eastern Oregon to southern Mexico and are all oriented in northern-south linear direction.
Glaciers are slow-moving masses made of ice, which are formed by the accumulation of compaction of snow. Glaciers are the remnants of an ice age. The most recent ice age in North America ended approximately 12,000 years ago. Glaciers play a part in carving mountains by grinding against the valley's sides. They are also responsible for moving sediments and debris. Glaciers always stay frozen through all seasons.
This video only uncovers a fragment of the entirety of the geology that California is created from. We hope that it's given you a better understanding of where the ground you step on has come from.